My name is Nakangu Teddy, Computer Science Year 3, Macquarie University. And I'm going to take you through our project, which is another topic, AI-driven visual story-based learning for accelerated refugee education. That is to do with fine-tuning multimodal models for Uganda's competence-based curriculum. So under this topic, we have some keywords. One, we have competence-based curriculum. And this is simply a learning approach that focuses on mastery of specific skills and competences rather than just covering content. So it is to do with students' progress by demonstrating their understanding and ability, not just the time they spend in class. So then we also have generative learning technology. And this is just AI-powered tools that create educational content, for example, quizzes, lessons, explanations, things like that. So these ones help us personalize learning by adapting materials to every learner's level. Then we also have interactive storytelling. So this is just a method that uses stories with user participation and in order to enhance their engagement and learning. So this makes this enables learners make decisions that affect the story outcome, which improves their critical thinking and even their retention. And then we also have multimodal AI. These are just systems that combine multiple types of data, like text, images, audio, even videos, to understand and generate richer outputs. And then lastly, we have no, not last. We have refugee education. This is just a type of education which is designed to meet the needs of displaced learners who face barriers, for example, interrupted schooling, language challenges, or even lack of resources. And then lastly, we have vision language models. And these are advanced AI models that link visual and textual understanding. For them, they can interpret images and even describe them in words, maybe generate images from text, things like that. So in this presentation, these are the contents we have, and they are listed down there. And then with the background introduction, we know that Uganda hosts very many refugees, and most of them are enrolled in accelerated education programs. Then these accelerated education programs struggle with very many challenges, including limited resources, language barriers, or even trauma-related learning gaps. So this project introduces an AI-driven multimodal content authoring system that replaces these manual 3D designs with vision language and generative models, for example, Unity and even Blender, which it focuses on fine-tuning models, already existing models. For example, in our case, we're using the Phi-3 vision, the all-mini L6V2, and then the stable Diffusion XL, Google TTS, MoviePy, and more. In this case, these models generate culturally relevant content that is CBC aligned and is multilingually helpful for the refugee children. Then we expect interactive scripts, storyboards, and even 3D animations in formats that are offline ready or even lightweight to be used in these low resource areas. So this approach enhances engagement, literacy, life skills, and directly supports quality education, peace, and also justice. Then we're able to review some related works in that we looked at different papers, mostly recent papers, and these slides includes the paper references. We're able to look at their models, contributions, and limitations, same as this one. And then when it comes to the problem statement, we know that the very many refugees in Uganda lack access to high quality and localized learning materials. Let's say the books they have are outdated or even cannot be able to access some of the resources because they are not available in these accelerated education programs. And then there is also limited devices or even internet, which worsens the gaps. So the computational problems we're looking at, one, we're looking at curriculum aligned content in that we want AI models that can generate lessons that are mapped to Uganda's curriculum-based, competence-based curriculum that ensures pedagogical accuracy, competency, alignment, and also structured learning flow. Then another one is multilingual support in that we are looking at integrating different languages, let's say Luganda, Kiswahili, English, because we know that many children who are in these areas come from different countries or even different areas speaking different languages. Then another one is cultural adaptation in that we intend to use GRAG, a layer that embeds local stories, symbols, even context. So the visuals and the narrations reflect the Uganda's culture, enhancing the engagement and relevance. Then lastly, we are looking at offline and low bandwidth optimization in that we want to apply model quantization. We want to make sure that the system can be able to run offline or even be used on low resource devices. Then, when it comes to the research questions, some of the things that we ask ourselves are how can the graphics-based content authoring framework support CBC-aligned learning in refugee education? Then, what methods can generate multilingual, culturally adaptive, interactive learning models that function offline only in low bandwidth settings? Also, how effective are these AI-generated graphics and interactive content in improving the learner's engagement, comprehension, and even retention in refugee contexts? And lastly, how can open access visual learning objects and templates be designed for scalability and reused by educators in NGOs in these fragile systems. And then some of the research objectives is that we intend to develop an offline fast modular graphics content authoring framework for CBC aligned learning modules, and then also to create animated and interactive learning modules using a lightweight or even open source platforms, and then to evaluate learners' engagement, comprehension, and retention in refugee education settings, and lastly, to produce open access visual learning objects and templates for educators and NGOs to adapt and scale. Then when it comes to our research contributions, we first of all developed a system to generate a structured lesson script for that are CBC with CBC aligned topics. Then we implemented an evaluation framework for assessing script quality, top alignment, and resource relevance using semantic similarities and readability metrics. Then we prepared and structured a CBC aligned topic dataset for lesson planning and automated content generation. And we also provided a data-driven insights into script coherence, top coverage, and even engagement potential to guide the future multimodal lesson development. Then when it comes to the methodology, this is the architecture, the architecture we are using. First, we have text input, which is passed on to the curriculum mapper, where we then generate a curriculum aligned prompt from the curriculum mapper. This system architecture is a multimodal system architecture, a multi-agent system architecture with different modules at different stages, which do different kinds of tasks and generate output that is fed to the next model to continue with the process. So then after the curriculum aligned prompt, it is then fed to a storyboard and a story and script generator, after which we obtain a script draft. The script draft is passed through GRAG, where it is made culturally relevant in that we generate a culturally augmented script that is then fed to the text encoder to encode the text, and then that the output from that is fed to the storyboard generator and also to the unit denoiser to remove the noise, do the cross attention, and then decode it. And then after that, we have a VAE decoder, which does the frames in which we obtain the storyboard frames. And then from the storyboard generator, we also get the narration audio file, which is fed to the video composer. The storyboard frames that are also generated are also fed to the video composer, where they are both synthesized and worked on. Then before the narration file is also lip synced with the audio and then the actions, and then we pass it to the lip sync generator, where we obtain a synced video clip that is sent to the composer, and then we obtain an instructional video. So allow me go ahead. Then when it comes to the dataset description, our dataset, we extracted that dataset as a team from it was extracted from Uganda Competence-Based Curriculum, which is a mathematics competence-based curriculum for accelerated education program. It has 26 topic levels. Those are the records. And then it is basically for level 1, term 1. And then our target variable is typically the competence, which defines the key skills, ability of the learners is expected to acquire. Then it has 13 features, which include subject levels, terms, competency, and more. Then from that data set, we are able to do an explorated data analysis where we obtain some visualizations. For example, we did a distribution by level. This one shows us that we're basically dealing with level 1. And then distribution by term shows us we're basically dealing with term 1. Then we did a distribution of competence text length. So this gives us an insight of how long the text we are to generate can be. And then the topmost frequency topics, this one gives us an insight that there is data we're working on. And then with a portion of topics by duration, this gives us an insight of how long the lessons are. And so it triggers us to think about how long the videos should be. And then the correlation matrix for the numeric columns, this one gives us how the distribution is. So when it comes to the results and discussion, we're able to generate some images from the models and their corresponding audios, as you can see from that slide, where we're a teacher wanting to generate a video that teaches learners how to add using a number line. And then we're able to generate a video at last.
Hello, young mathematicians. Today's adventure takes us into the world of adding numbers. We will use something called a number line.
So because of time, I'll not play it at all. But then that is the video we're able to generate. So the issue is that the video is not yet having motion. That is a challenge we are facing right now. And then the voice, we intend to work on the voice by providing the model with a local voice. But besides that, we're able to do an evaluation report for the CBC lesson generated from this video. using the metrics, user request, script metrics, topic metrics, retrieved resources, average semantics similarity, and also average readability. And we're able to get the details like what the request was, the scenes, were the words matching, what was the overlap score, which was 0.5, and then the similarity, which was 0.498, and the average readability, which surely shows that it was fairly easy to read. That is the script.
Hello, young mathematicians.
Then allow me go to the model selection. With the model selection, this table shows the models that we selected to use, and which included the Phi-3 Mini 4K instructions in all Mini LM, L6V2, Stable Diffusion XL, Google TTS, Wave, 2lib, MoviePy. So this table includes their purpose, their strength, limitations, and also resources. Reasons for selection. For example, for the Pi, it's for text understanding and generation. The key strength is it has it's a compact LLM. It has 4K context. It is efficient and also aligned. So the limitations are that it is weaker than the larger LLMs. And then why we chose it, because it's accuracy, high accuracy per size. So even other models, they're all explained in the table. Then when it comes to the limitations, some of the limitations we found is that the images generated did not fully capture the exact meaning, all the instructional content of the script. But then to work with that is that we intend to fine-tune the Stable Diffusion XL with Uganda educational and cultural images to improve the contextual accuracy. Then with the voice generated is not in line with the local context. Still that we want to adapt the Google TTS with local voices. And then the generated images also lacked motion, like I said earlier. So we want to integrate motion generation models, or looking into doing the model. And then with the limited resources, for example, the GPU will always crash running out of memory. So currently we are clearing memory after each output, but we intend to also employ other means. So to conclude, the pipeline was a successful demonstration of how this multimodal AI combining the text, image, audio can create education storytelling videos, but still lacking. And we're working on that. Then for the next steps, we intend to transform static images into animated sequences, like using video diffusion models. And then we conduct a pilot study with teachers and learners to measure comprehension, engagement, and even retention. So we're also intending to apply model quantization to work on that memory theme, because we really got challenged. And then also include regional languages like Luganda, Kiswahili, and more. So with those, that is what we've done so far. And we intend to fine-tune these models to work better and achieve our goal. So we'd like to thank our supervisor, Mr. Galiwango, and the midterm examiner for their invaluable feedback and guidance always. Thank you.